Hey, welcome everyone. My name is Virginia. I'm the press secretary at Stand.earth. Today we are here for a press conference announcing the release of a report titled An Investigation of Air Pollution on the Decks of 4 Cruise Ships. With us today we have Dr. Ryan Kennedy, an assistant professor at the Johns Hopkins University Bloomberg School of Public Health, and Kendra Ulrich, the senior shipping campaigner at Stand.earth. Stand, which commissioned the study, is an international environmental organization with offices in the U.S. and Canada. We have 20 years of history working to stop companies like 3M and Victoria's Secret from using old-growth forests in their paper products. More recently, we were involved in pushing Starbucks to make a recyclable paper cup and Levi's jeans to transition its supply chain to renewable energy. One of our core campaigns at Stand.earth is focused on the climate and human health impacts of the shipping sector. And really quickly, I'd like to mention that the study, the press release, photos and video from a ship and a backgrounder are now posted on the Stand.earth website. You can go under latest to view them there, and the press release has also been sent out into your email. I'm going to go ahead and introduce Dr. Kennedy and Kendra and let them say a little bit about themselves and take it away. So, Dr. Kennedy.
Hello, this is Ryan Kennedy. I'm in Baltimore, Maryland at the Johns Hopkins Bloomberg School of Public Health. I'm faculty in the Department of Health, Behavior, and Society. I've worked in air quality issues for over 15 years.
And Kendra with Stand.earth.
I am the senior shipping campaigner with Stand.earth. I recently joined Stand a year ago. Prior to that, I was working with Greenpeace in Japan and in Europe and coordinating their international energy campaigns. I am excited to be here and thank you all for coming.
So I'm going to let Dr. Kennedy and Kendra move right into talking about the study, and then there will be some room for questions at the end of the press conference. Thanks.
Thanks very much, Virginia. So I'm going to spend a little bit of time now talking about the work that I did to try and understand the air quality on the decks of different cruise ships under different conditions. Of course, it's so exciting to talk to anyone as a researcher about my scientific studies, so thank you all for coming. And I will do my best to explain it in a way that's accessible, but of course we have question time at the end as well. I was very interested in understanding what the air quality was in different locations on the decks of cruise ships that were departing from different ports and different, I was curious about how the air quality might differ based on where on the deck I was and further different times of the day. And so I designed a study where I used an air quality monitoring device, a P-track that's manufactured by TSI, which is able to measure concentrations, particle counts of very small particles of constituents in the air. We're in the field of public health. We're very interested in understanding air pollution, particulate matter that is often characterized by the size of the particle. We are very interested in particles that are smaller, the ones that we might call ultrafine particles or even nanoparticles, because these particles are so small that they have certain characteristics. The physiochemical characteristics of these particles are of great concern for health. There's a few things I wanted to make sure that we talked about. First of all, because the particles are so small, they have a lot of surface area relative to the mass of the constituents in the air. And so if you have a particle, an ultrafine particle that is made up of something that is perhaps toxic, like a polycyclic aromatic hydrocarbon, a PAH, if it's very small, then the likelihood that that particle is going to interact with a cell in your body or be picked up by your bloodstream, for example, and transported somewhere else in your body is greater. The opportunity for very small particles to impact health is greater by the nature of their physical characteristics. And so that's one of the reasons that we're very concerned and interested in ultrafine and even nanoparticles. There is evidence that these small particles have consequences for human health, including cardiovascular disease. It can exacerbate symptoms like asthma. And the concern is that exposure to very small particles likely affects everyone that's breathing them. Of course, people that are predisposed with cardiovascular or pulmonary conditions, of course, are at greater risk. The work that we did, the work that I did on board the cruise ships, to our knowledge, has not been done at this scale or this degree of comprehensiveness before. And there's some reasons for that. It's obviously difficult to collect these data. You actually have to go on the cruise ship. You have to be a guest to access that space. And the way and the nature of doing that in a manner that doesn't disrupt or impact anyone's vacations is really important. So the work that I did, we worked really hard not to impact anyone's vacation, and we worked really hard to design a study that was comprehensive in terms of what and how I collected those data. The ships that I was on board, one of them left from Port Canaveral in Florida, and we went to the Bahamas. I did another cruise that left from Galveston in Texas, and we visited throughout the Western Caribbean and Mexico. I had one cruise where we left from Vancouver and journeyed south to Los Angeles. And the final cruise that I did left from Los Angeles and traveled north and then back down south into Mexico and returned to LA. Like I said, the measurements were taken using a P-track, which is an ultrafine particle counter. And the methods that I decided to use set the device to record an average reading of particle counts every minute. The P-track is commonly used by people that work in occupational health that might go into a workplace, for example, to try and understand what concentrations of particles might be present. And the ways that the equipment has been designed, you can take a spot measurement. So the device has been structured so that you can take a 10-second sample to characterize what the air quality is at that specific moment, an acute measurement. I decided to log data over longer periods of time, several minutes. At least on the last two cruises, I was able to do every test at least 20 minutes long, which means that I'm collecting a lot more data to better understand what the particle count might be in that environment. And that's in some ways more conservative, the orientation of the strategy for my sampling, than some other studies. But I thought it was more consistent with respect to trying to understand what might be a reasonable exposure that a person might experience. Obviously, in a cruise ship, some people will stay in the same spot for hours and hours, and some people will be transient in terms of where they're going. But it was a totally reasonable sort of expectation to say that people are probably hanging out for 15, 20, 25 minutes in a location. So that was the motivation behind the methods there. I think that's sort of enough for now. Kendra, are you going to want to talk more about the specific ships, or?
Yeah, I can definitely do that. That's not a problem. So I just want to reiterate here that what Dr. Kennedy found on board was shocking. Some of the particulate counts were comparable to or worse than a bad day in some of the world's most polluted cities like Beijing and Santiago, which we will see in the report. While the ship was underway, the particulate count in the stern area, that's the area at the back of the ship, was consistently the area where we had the highest counts. The other really, really important piece of this is that the highest counts were frequently found on the running track and in the exercise areas. I myself am a runner. I found it absolutely shocking that they would have a running track around a smokestack or behind a smokestack. They also had on some of these ships lounge areas, recreation. On the lower decks, there were frequently swimming pools and other things for people to congregate behind the smokestacks at the back of the ship. And this is consistently, again, when the ship is underway, where the highest particulate counts were. A few things that I do want to note. First, let me talk a little bit about the Carnival campaign itself, and then I'll sort of delve into the regulatory frameworks that help to contextualize this study. So Stand.earth is campaigning to get Carnival Corporation to switch away from using one of the world's dirtiest fossil fuels, heavy fuel oil. This is bottom-of-the-barrel sludge that is left over after the oil refinery process. It is high in sulfur, it's high in polycyclic aromatic hydrocarbons, it's high in toxic heavy metals. We do know that the emissions from combustion of heavy fuel oil in ship engines can have significant contaminants in it, which is why these ultrafine particulate counts are so concerning. Most of the ships in Carnival's fleet are fueled with heavy fuel oil. Stand.earth is really focused on getting them to switch away from this in the short term to cleaner burning low sulfur distillate fuels and install the appropriate filters in order to address the ultrafine particulate pollution. We are a part of an international coalition, a global campaign focusing on Carnival Corporation. This study was only done on Carnival Corporation ships. So there are two Carnival cruise line ships. There's one Holland America ship, which they market as sort of their more upscale brand ship. And then in addition to that, of course, the Princess ship. A couple other things about Carnival before I move on to the study findings and the scrubbers. So Carnival, the reason Stand is focused on Carnival is it is the largest actor in the global cruise sector. So there were 26 million people that went on cruises last year approximately. Of those, nearly half went on a Carnival Corporation brand. This industry giant has 10 subsidiary brands. They operate globally in oceans throughout the world and have 40% of the global market share. Because of that, they are also the largest dues-paying member of the Cruise Lines International Association. That is the trade organization that represents the cruise sector at the UN International Maritime Organization, or IMO. The industry has been, CLIA, has been really pushing to make sure that a loophole for a type of technology called exhaust gas cleaning systems is preserved in those international regulations in order to be able to continue using heavy fuel oil as stricter fuel standards come into place. Just one other quick connection with Carnival as well. The CEO of Carnival, Arnold Donald, is also the global chair for CLIA. So very, very tight connection there. Because of that, what this industry giant does can have a huge effect and set the standard for the rest of the industry. Because there are millions of people worldwide that are going on these cruises, this is an important public health issue. But not just for the passengers on board. This is also an issue globally for port communities, particularly those that are, key destinations for the cruise sector, and as well for coastal communities. Studies have shown that nearly 70% of global ship emissions happen within 250 miles of shore. This pollution can travel far inland and expose millions of unsuspecting people to ship exhaust emissions. Because of that, what is happening offshore while these cruise ships are traveling down the coast can have a significant impact on the health of the communities that they're passing. One of the important things to note is that in the United States and in Canada, there is an emissions control area for sulfur emissions. And again, going back to what I was saying before, the scrubber loophole, the exhaust gas cleaning system loophole, enables them to comply with that emissions control area, or ECA, by having those open loop saltwater scrubbers in place. These systems effectively take pollution out of the air and discharge it into the water. There have been numerous concerns, so there are ports and entire countries that are banning the discharges from open loop scrubbers because of significant water pollution concerns. Removing pollution from air emissions and making them water emissions is not a solution to the pollution problem that the cruise sector has. One of the really, really important pieces of this study, and the reason that we went twice to California, is because as you come down the coast of the western United States and North America, there is a specific restriction in California. So 24 miles, nautical miles off the coast of California, the state of California has banned the discharges from open loop scrubbers. They have also required that ships use cleaner burning fuel. So separate from Dr. Kennedy's study, SAND has downloaded the AIS data, the ship tracking data, global positioning data, for the cruises that Dr. Kennedy was on. What we were looking for was, are there trends in terms of particulate counts, and were the ships actually within that 24-mile zone off the coast of California? What was quite interesting to us was that off the coast of California, as that ship, the Holland America ship that went from Vancouver to Los Angeles, came down the coast, they were pretty much within 24 miles until they got to California, at which point they headed further out to sea so that they were no longer in that restricted area. Again, going back, 250 miles off of shore have been shown in studies to have an impact on public health. So the fact that Carnival happened to travel a little bit further out to get around the regulations does not address the concern that California had in instituting those regulations in the first place. They want these companies to be burning cleaner fuel to protect the public health of their citizens. And that is also the primary objective of the emissions control area. Similarly, there is another regulation coming up in 2020 at the IMO. This will ban the use of high sulfur fuels, cap the allowable amount of sulfur to 0.5%. This should effectively ban extremely dirty fuels like heavy fuel oil, except that there is that scrubber loophole in that regulation as well. Companies do not have to wait to be forced in order to do the right thing. Carnival could today switch to cleaner burning, low sulfur distillate fuel. The reason that they are not doing this is because of the cost, it would appear. There doesn't seem to be any other viable explanation for why they would be, continuing to use heavy fuel oil, given the environmental risks. And this is not just related to, of course, public health and air emissions, but also environmental risk, spill risk, et cetera, related to the use of ultra-dirty heavy fuel oil. So again, we are asking this company to step forward to become an environmental leader in the sector, to address their public health and their environmental impacts. I'll hand it over to Ryan to talk a little bit more about the study itself.
Sure. So that's a really good rationale for the sample selection, as we would say in our research. I'll take a step back onto the ship and explain how I designed the study so that we could begin to quantify and understand what the air quality was like on the deck. And so ships largely have a smokestack, or sometimes they call it a chimney or an exhausting system, and it typically is towards the back of the ship, the stern, And when a boat or ship is moving forward, it's creating its own sort of wind conditions that is going to create an upwind and a downwind space within the ship, on the deck of the ship. Obviously, in the environment, when we do observational studies, there's lots of things we can't control, like local winds. So those are going to differ on any given day and space. But the advantage of doing an observational study on a cruise ship that's moving forward is that we have created, by the nature of the ship and movement, we have an upwind and downwind space. So I designed the study so that I was measuring concentrations of particles using the P-track in the bow area, which is for or in front of the smokestack. And then I identified on each ship 2 areas that were aft of the stack, so more towards the stern, the back of the ship. And arguably then, those are spaces that are now downwind of where the exhaust would be coming out of the ship. And I was able to do a sampling where I would cluster my analysis. I would identify a time during the day where I would go to the bow, and then the 2 spaces in the stern. And I mixed up the order in which I was doing those observations, but they were always done in a set of 3. So I could begin to internally compare some of the results. And the reason for that, of course, is that ambient or background concentrations might fluctuate throughout the day. Kendra explained that the ship is obviously moving closer or further away from shore. Land mass could be a source, for example, of ambient or background particulate matter. There could be road dust or other sources of a particulate that might be drifting from land and impact the air quality. The argument that I would have is that those background levels would probably be fairly similar whether or not I'm in the bow or in the stern areas. And so we can begin to ascertain where or what might be sources of ultrafine pollution in those environments. And what we were very concerned also that there might be other sources that could be beyond or over and above what might be contributed from the exhausting system. So you think about a cruise ship, they're going to not only be providing propulsion for their ship, but they also need to generate electricity. So that is going to have additional emissions as well. And probably exhausted through the same stacks or chimneys. There could be cooking impacts. For example, there's a lot of people on board a ship, and they need to cook, and different types of cooking. You know, when you're burning things, particularly, you'll get a whole range of particulate that could be contributed that way. In theory, things like laundry might also be adding. If you're drying fabrics, there might be particulate matter. I don't know what that profile will look like in terms of fine versus ultrafine versus nano. But again, these are things that we needed to consider, and so my sampling ensured that I was doing studies at different times of the day to try and mitigate or address variation that might result from cooking or laundry in particular. And also doing the studies across 4 different ships and hours and hours of monitoring, I'm able to take a step back and take a look at what we found in our results. The first thing that I was doing was looking at absolute concentration. So what were the findings? Were they elevated? And in general, when we were on the ship and it was moving forward, I consistently found that in the bow area, 4 of the stack, that the concentrations were lower than the readings that I was picking up downwind of the stacks. And when I did some statistical testing, these are averages, they're means, so I'm using a t-test to see if the actual difference between those means was real, statistically significant, and it was. When I compared the bow to either of those places in the stern, it was always significantly higher in the stern areas. When I compared the 2 environments on each ship in the stern areas to each other, they were not different. The ships are all designed slightly differently. In the report, I've included some of the schematics so you can get a better sense of where the stacks are relative to other spaces on the ship, and that can help sort of contextualize it. But where possible, on one of the ships, like Kendra said, there was an area in the stern that was set aside for physical activity, including spaces for kids to play. In the first couple of ships I did, the running track was the whole back half of the running track was downwind of the stacks, and these are very curious. Our colleagues in Europe that have done some studies like what I did, although at a much smaller scale, they found similar findings, that the area on the running track was where the concentrations of particulate counts was the highest. And so that's what we found. And I have the absolute numbers that are here, and I can go through some of them, but what I ended up reporting in the final report were averages. So if I did a 30-minute sample, for example, I averaged the concentrations over those 30 minutes. But I also reported maximum and minimum readings to give you a little bit of a context of how different concentrations might be fluctuating. Like I said, there would be a lot of factors going into what my readings might have been. Although the speed of the ship is fairly consistent, and we would sometimes check when we were on board, there's different ways to determine, and sometimes the captains actually announced how quickly we were going, it would remain fairly steady. So the impact of the propulsion of the ship on the plume of the exhaust would be relatively stable from that perspective. But what you can't control, obviously, is the natural winds that are going on. And the concentrations compared to the bow from the stern on different ships were several times different, 3, 6, 7, 8 times higher. And I was getting maximum concentrations, acute 1-minute samples, in some instances over 100,000 parts per cubic centimeter. The way we consider sort of ultrafine particles, for example, when I did some measurements in a park in Florida before I boarded one of the cruise ships, I went down to Jetty Park in Port Canaveral. It was an onshore wind, so there's probably no immediate impacts from traffic or other sort of sources, and I was getting readings less than 500. So 500 in a park environment on the stern of the ship, over 100,000. So that gives you a bit of an idea about the relativity and the absolute impacts that the concentrations that I was measuring. And Kendra mentioned too, when we begin to try and compare what the readings I measured mean in the context of other environments, it's very important to make sure you're comparing apples to apples. So when I looked in the literature, the peer-reviewed literature, to try and understand what is ultrafine particle counts in some of these cities that we were concerned with, a place like Beijing, I made sure that I was comparing studies that had also used a P-track. The P-track has a specific particle range from a few nanometers right up to 1.0 microns. And so, and I should mention too that when you're measuring and trying to understand what the particle matter is in the air, some people might be familiar with things like PM 2.5 or PM 10, and we tend to report those concentrations in terms of the mass, so how much of it is in the air. And it's relatively easy to monitor that, even with mobile units. But again, when we're considering the relative importance of ultrafine, the mass, these are very small particles, so reporting the overall mass is not as relevant. It's a better indicator, in my opinion, to be reporting the counts. So how many little pieces of potentially bad types of particles are in the air. And so the concentrations that I'm picking up in the ship, they were comparable to a lot of these different cities where we might associate with really extreme pollution events. The absolute impact on that is hard to ascertain comprehensively, but what we have agreement on across the public health community is that ultrafine particles, particularly if they've been produced by burning petroleum products, whether it's heavy fuel oil, marine diesel, or even automobile diesel, these are not healthy. And I guess I wanted to sort of conclude by reminding folks that IARC, the body, the organization that we in public health rely on to make determinations about whether or not a product is a carcinogen, for example. The exhaust from diesel from automobiles was classified as a group 1 or known to cause cancer in humans. And so that's, I mean, and if we're to compare directly heavy fuel oil to automobile diesel, we know heavy fuel oil has in the order of thousands times more sulfur content, for example. So even something like automobile diesel exhaust, we have to just remind ourselves it's dangerous. It's not a healthy thing for us to be exposed to. And I think, and if we're wrapping up too, I guess because I get asked a lot, like, was it any fun going on a cruise to do some of this work, and what sort of things did you learn, Ryan? And to be fair, I had never gone on a cruise prior to this, and I'm not sure it was on the list as things that I had up there to want to do. And I was quite impressed on all the different cruise ships that I went on about the quality of customer service that I witnessed, the really hardworking people that are on board those ships. And we know there's tens of thousands of people that work on these ships. I think from the media perspective, it's probably very impressive to know that millions of people go on a cruise every year, millions of passengers, and the trend has been going up. I include that in my report. There's also tens of thousands of people that are working in these environments, and it's a very important dimension to this because depending on your role on the ship, you might be in some of these areas completing your tasks and not have a lot of choice about when and where you're in those environments that my studies are suggesting probably have elevated levels of ultrafine and other types of particulate matter.
Yeah, great. Thanks for that, Ryan. And just a few final thoughts from me as well. One of the things that I found really surprising, I also accompanied Ryan, Dr. Kennedy, on the last cruise on the Emerald Princess, really to get a feel for how the study was being done, and also to get a sense for what cruising is. I also had never been on a cruise before, and did not have a burning desire to be on a cruise, but it was quite interesting. And again, many of the staff that are working there are coming from developing nations. Most of them are from nations with weak worker protections. They are on board these ships, and as Dr. Kennedy said, there have very little choice about where they might be working or standing. On the ship I was in, there was a bar at the back of the stern. There was staff that, of course, had to be there in order to be able to serve anybody. There were pools in the lower stern area. And so these staff people that are being required to work in these environments, of course, are potentially being exposed to extremely high levels of ultrafine particulate pollution. The World Health Organization has called air pollution the new tobacco. This is a very serious public health risk, and one that these companies can address, and Carnival needs to address. This is clearly an unacceptable level of pollution for passengers or staff, not to mention, of course, the potential exposure of people on shore. With that, again, Carnival has stated that they value the environment and they value public health. They value human safety. Their practices are not aligning with their own higher standard. We are asking them to step up, to become a leader, to stop using heavy fuel oil, starting with very vulnerable environments like the Arctic and subarctic, but in their global fleet, and to get off of fossil fuels completely. Switching from one fossil fuel to the other isn't a long-term solution. So we need for them to switch in the immediate short term, because they could do it today, to cleaner burning fuels, get the appropriate diesel particulate filters on the ship to address this ultrafine particulate pollution and help to start mitigating some of those public health risks that are posed by their combustion of heavy fuel oil. With that, I think we can open it up for questions.
Certainly. At this time, if you would like to ask a question, please press the star then 1 on your touch-tone phone. You may withdraw your question at any time by pressing the pound key. Once again, it is star then 1 to register to ask a question, and we'll pause for a moment to allow questions to queue. Again, that is star then 1. And we can take our first question from Alan Newhouser with U.S. News and World Report. Your line is now open.
Hey, thanks for the call. Two questions for you. First, how do the health impacts of ultrafine particulate matter compare to the health impacts of PM 2.5? And also, forgive me, I thought that there was a mention in some of the materials to the effects of this pollution or its concentrations for these communities that live near these ports. So I'm curious if there were any findings in terms of the concentrations within these communities on land and what the implications were there. Thanks.
Thanks, Mr. Newhouser. This is Ryan. The health impacts from ultrafine particulate, in some ways we're ahead of the science on this issue. We've had decades of monitoring for PM 2.5 and PM 10, and we're able to really clearly point to some of the, using epidemiological data, what the health consequences are from some of that exposure. There's a couple things that are important to understand. Ultrafine particulate, we don't have the networks nationally or even internationally to understand concentrations, so it's really difficult to link the health data to the environmental data. And secondly, it's really hard to tease apart sort of some of the contributing impacts that UFP would have compared to PM 2.5, for example. We'd have to, if we wanted to really solidly ascertain or communicate the relative risk or the absolute risk of exposure to UFP, we'd have to have a population that is only exposed to that particle size range and not have been exposed to others. The general consensus from public health and environmental health folks is that ultrafine particulate matter is not safe. It's obviously relevant what the source of the UFP is. If you're being exposed to very small particles and they're toxicants or carcinogens or mutagenic, these are of deep concern. But because of the sort of issues around our monitoring network, for example, we don't have global standards with thresholds for safety, for example. Is that sort of, does that answer your question, Alan?
Yeah, no, that's helpful. I think it does. I guess can you say why you measured then ultrafine particulate matter instead of, say, 2.5 or PM10?
Oh, yeah. So there is a literature that has studied the particle size contribution from both marine diesel and or heavy fuel oil, rather. And the particle size from the exhaust from those types of fuels, it has been characterized, and it lines up very well with the measurement field that the P-track is able to measure. And so it was, if we were investigating the contribution of ship exhaust on the air quality, that particle size range was a very logical one to pick.
Got it, thank you.
Once again, if you'd like to ask a question, please press the star then one on your touch-tone phone. We can take our next question from Bob Weber with the Canadian Press. Your line is open.
Hi, a couple of questions for you. First of all, I wonder if you can comment. I mean, most of the exposure we'd be talking about here for people is very short term, like a week or two at most. And I can wonder if you can comment on the dangers of short term versus chronic exposure to these kinds of particulates. And I'm also wondering, you have your sample size from the ships is fairly small. There's 4 of them, and I'm wondering if there's any concerns with just the way you've had to go out taking samples here somewhat surreptitiously, as I understand.
Right. Okay. So the something that surprised me on one of the cruise ships is that I had dinner with a couple, for example, and they had just boarded the ship, and they were about to be on it for months. So some people do actually cruise for a few days, or I think one of them was a 300-day route on one of the cruise lines. Kendra might have better knowledge of the range there, but so there is potential for longer-term exposure. There is a literature also on the health effects of acute exposure to specific pollutants, and I can certainly, Mr. Weber, put you in touch with some of those resources, but even short-term acute, I mean, sort of 5 minutes range, we have evidence that that can affect there's animal models and human studies that can link to a physiological impact from even short-term exposure. And of course, like I said earlier, there would be people that are more vulnerable, people that might have asthma. There would be concerns. Certainly my son has asthma. If we were to go on a cruise as a family, I would not want him to hang out in the stern of the ship. The challenges with respect to the sample size, with observational data, one of the beauties is that it is what I've measured. I've reported in the report, we have every single test that I did. In an ideal scenario, I would have had multiple machines running all the time. There are some challenges with the P-track, the very nature of the way the device works. It's a condensing counter, meaning that it performs its counting using high-grade isopropyl alcohol. And the alcohol eventually evaporates and you have to restart it. So some of my sampling was impacted by the very need to just sort of recharge the device and use it again. The sample size, I would say that the 4 ships were all a little bit, well, 3 of them were quite different to each other in terms of the physical layout, where the stacks were. But as a scientist, what I view as what was common across the findings, and that was that in each instance, even though the stacks might have been in a different physical location, the number of passengers and size of the ship might be different, what was similar across all of them was this finding that the concentration of particulate matter in the bow was lower than in the stern. So again, is that fine, Mr. Barber?
Well, is there a chance that your conclusions could have been distorted by the fact that you weren't able to have like a 24-hour continuous monitoring system, that you had to take them like somewhat undercover, and perhaps you were just taking them at a time of day when the wind was unfavorable? Is that a concern for you here?
Sure. I mean, it's hard to argue counterfactual. There could have been differences when I wasn't measuring. I'll say that the first couple cruises I did, it was so windy, Mr. Weber, that they actually shut down the track area on one of them, one of the ships. So even though it was so windy, and you would think such high sort of natural winds would, I was still able to detect a difference, sort of the concentration count. I got up in the middle of the night to do some of the studies, early morning, late night. Sure, and that was not obviously wind patterns have a course throughout the day that sort of, it's calmer at night, although in some of these, when we were in the middle of the Caribbean, or particularly in the West Coast, the winds were pretty steady at different times. I would see fluctuations within a 20-minute sample, but taking it over 20 minutes, that's a fair way to sort of begin to even out what the concentrations might be. And then taking them multiple times during the day and over multiple days, multiple ships, multiple locations, different routes, same trend. Is it always bad everywhere on the ship? No, I didn't find that. Did I find concentrations in different locations that were much higher than other locations on the ship within, I would hang out and then quickly go to the other space, but even the ambient conditions could have changed during that 30 minutes. So there are limitations to what I did. I think it was reasonable given that it was just me, and I needed to be respectful of, had I been able to sort of leave things out and sort of maybe, I could even argue that the device sometimes might have been a foot or two shorter than where my nose was in terms of the intake, so is that fair in terms of what it's measuring? I made every effort to be consistent with my methods across environments, and I wasn't able to measure everything everywhere always. So. Okay.
Do you intend to try and publish this study?
I'd like to try and publish it. The expectation for this report was, of course, to be as transparent as possible, and that meant that the appendices include the results of every test. So I'll need to sign a journal that doesn't feel like it's already in the public space.
Of course.
Right.
Yeah, and just to build on what Dr. Kennedy was saying, this study, again, is the most comprehensive study of its kind. This was across 4 ships, which may seem like a small amount, but it includes different locations. We had 1 ship that left from Florida, 1 that left from Texas, 1 from Vancouver, 1 from LA going down to Mexico. So very different locations, very different conditions over many, many days in total, with multiple samples per day at multiple different times throughout the day. And we're seeing a consistent pattern. The other thing that I will say, again, that was quite interesting to us as we were looking at the AIS data for these ships, that's the ship track where they were traveling, was that the particulate counts when they got close to the shore in California seemed to be much lower than when they were outside that 24-mile zone. In addition to that, the ship that I was on, the Emerald Princess, spent quite a bit of time in Mexican waters, and that is important because neither the North America ECA, Mexico is not a part of the North America ECA for whatever reason, and the California regulations in terms of the scrubber ban and the cleaner fuels are not in place. And some of the highest particulate counts were found there. It would certainly appear again that they went outside of the 24-mile zone in order to be able to use heavy fuel oil, or at least that would have permitted them to do so. And we saw very high counts there as well. So this is a public health concern. It is a concern for people that are on board the ship for those short-term acute exposures. It is also a concern. We had a lot of folks that were talking about the fact that they go on multiple cruises many times a year. Many of them are senior citizens, folks that may have heart or other cardiovascular issues, who could be potentially being exposed to very elevated levels of particulate matter that could pose a serious threat to their health. And in addition to that, of course, just going back to what I was saying before, this isn't just about who's on the ship. It gives us a very good sense of, the type of particulate matter that you might be exposed to on deck and is coming from that exhaust. But this is also very much about, port communities and coastal communities who are potentially being exposed to ship exhaust. And some areas, for example, in Alaska, you have significant ship traffic, cruise ship traffic. And this is true in Europe, in the Norwegian fjords, and elsewhere as well. So this is a pervasive public health concern that extends far beyond just a short-term acute exposure on board the ship.
Once again, ladies and gentlemen, if you would like to ask a question or pose a follow-up, please press the star then 1 on your touch-tone phone. We can go next to Monica Gull with News 1130.
Hi there, yes. I was hoping, I think you're the first person kind of asked this as a follow-up question, not really sure got answered, but if you could kind of expand, I know the study focused on the cruise ships itself and the air quality, but kind of talking about the effect this may have on these port cities on the shore. Some of these cities see these cruise ships coming, several times a day, and whether or not this sort of air quality is having an effect on the shore, on the inland area.
Dr. Kennedy, did you want to address that?
I can. I didn't take the P-track off the ship with me when I went ashore. It was in some of the ships we didn't actually port at land. We had to be ferried in. Not to say that the ship then the exhaust wouldn't impact still at land. There's more literature in this area, in the environmental health and public health literature, trying to quantify the impact that ship exhaust has on the health. There was a study in PLOS One, maybe 18 months ago, that estimated that tens of thousands of people have their lives shortened because of exposure to shipping exhaust. it's a little bit easier to study. Our study was, like Kendra said, probably the most comprehensive to try and understand on the deck of the ship. A lot of the port communities have air quality monitoring networks. A lot of the port communities as well in river cruising sectors, that's very relevant. The ships, when they come into port, I mean, there's thousands of passengers and often over 1,000 people that work on these ships. It's almost like a small town sort of pulling up. And the ship is, in most cases when I was cruising, the ship would, even though the propulsion, the engines for propulsion wasn't used, it would still need to power electricity, for example, air conditioners to keep the ship comfortable for the passengers. So there was always something being emitted out of the smokestacks, even when we were in port.
Yeah. And just to build on what Dr. Kennedy was saying on that, as far as port communities, we know that ship exhaust impacts health of port communities. We know that there are higher rates of childhood asthma and other health effects in port communities that have been attributed to exposure to ship exhaust. So this is a significant concern, particularly for areas where you have large amounts of ship traffic, particularly these cruise ships. On average, they burn 200 tons of heavy fuel oil every single day. So this is a vast fuel that they are consuming to power these mega ships. When they're idling in port, just like idling your car, you have a significant amount of air pollution that is a result of that. And one thing I do just want to go back and reiterate as well is in addition to long-term exposures of port communities and of passengers, we are also talking about the long-term exposure over years and years of staff on board these ships.
Okay, thank you.
Thanks, Ms. Gall.
And we can now return to Bob Weber with the Canadian Press. Your line is open.
Thanks. I'm sorry if I sound like I'm belaboring this. It's been a similar question, been asked a couple of times, but I'm wondering if there are any specific health threats that are linked with this level of the ultrafine particulate matter.
Yeah, no, it's Mr. Weber, it's not belaboring it. I can't point to a specific health threat that would be common across an entire population. I think some of the levels that I recorded are remarkably high, and they're concerning. The limitations for me is that I don't know in absolute sense what the constituents are of the ultrafine particulate. To do studies like that, the common methods that would be employed would be to use canisters and pumps and to be on board the ship, pumping air over a time period into and then sending that to a lab to do mass spec or gas spec to ascertain the specific constituents, what proportion of the particulate was polycyclic aromatic hydrocarbon, what aspects were specific known harmful constituents. If I had those data, it would be a lot easier for me to point specifically. But of course, no one wanted me to be on the deck and the stern with a canister pump running while they're having a vacation. So it's
Can I ask you then, what would be a good way to characterize your findings here? I mean, we're not talking about specific health threats, but you say that the levels here are concerning, something we should take seriously and look more into. How would you characterize how these findings should be received?
I would characterize these as very compelling findings, that there is a significant particulate matter somewhere between the stern and the smokestacks. So,
okay.
Yeah, and again, just to follow up on that, in terms of the concerns, I mean, the report itself does talk about the fact that there are cardiovascular impacts from exposure to ultrafine particulate pollution, that is a risk. There are studies that are indicating that ultrafine may be more dangerous than that PM 2.5, which, as Dr. Kennedy was saying, is what you always hear about air pollution, generally speaking. So these may be even more of a concern. In addition to that, we know that the exhaust from heavy fuel oil has harmful constituents in it. Just to go back to what Dr. Kennedy was saying about the reason we chose the P-track for this study was because it very closely mirrors what we would expect to see from diesel and from heavy fuel oil. It is that ultrafine particulate matter that coincides with the particulate profile from the combustion of these petroleum products. And again, diesel is already classified as a known human carcinogen. Heavy fuel oil has, because it's a waste product from oil refineries, it is concentrated in terms of the contaminants that are in it. And so the levels of dangerous constituents that are likely in the particulate matter that we measured, things like those polycyclic aromatic hydrocarbons, toxic heavy metals, nitrous, nitrogen, and sulfur emissions. These things have potentially significant impact on public health. This is very much a solvable issue. Again, Carnival could be switching to cleaner burning fuel.
And this does conclude the Q&A session. I'd like to turn the program back over to our presenters for any additional remarks.
Ryan?
Oh, that's us. No, I thank you for those excellent questions. I think what we've presented here is really unique, and I was excited to be part of this study.
Yeah. Thank you, Ryan. And I just want to say that, it was fantastic working with Dr. Kennedy of Johns Hopkins. This study clearly shows that there is a serious public health issue related to the choices that Carnival is making in terms of its fuel choices and pollution control technologies. So again, it is fundamentally critical that this company step up to the plate and clean up its act. This study was funded by Stand and our concerned supporters, around the world that helped to make sure that this type of important public health information is done and available to the public. So thank you for all of you for coming, and thank you again to all of our supporters that helped make this study possible.
Thank you for your participation. This does conclude today's program. You may disconnect at any time.